All right, if everyone is ready to go, we'll go ahead and get started. Hopefully you can see the screen well enough. So I'll go ahead and get started with today's session. We've got a couple minutes late, but I see that we've got quite a few people here. So welcome to Percona Live Online, and getting near the end of the second day. And we'll go ahead and go here. So throw a little bit of Hobbit humor in here, but the sharding tale, then, now, there, and back again. And really what that's talking about is a lot of the changes. We'll be talking about some of the new things. We'll be also talking about some of the history that has happened with sharding over the last couple of years. There have been quite a few changes that have been fairly instrumental and some exciting things coming. And a lot of people use some of these things, and a lot of people don't. For example, transactions was brought into play a couple of years ago, but for the production environment, I actually don't know that many people that are using them, but always interested to hear more. I'm Kimberly Wilkins, so MongoDB technical lead at Percona. So having a little bit of a screen issue here. It's playing over here, and my camera's here, but couldn't get that to work today. So anyway, technical lead. So hopefully you guys are having a good time, but let's go ahead. Also, hold any questions. We've got a lot of material. If you can hold any questions till the end, and then we'll either pick them back up or etc. I have my links and all the information there for you as well. So Percona and MongoDB. Percona's been offering MongoDB for a little while. We started offering managed services last summer, and before that had the support for it. So that was a big thing. I've known about Percona for a long time. Just came over to work for them last August, but I've been presenting at the conferences and being part of their selection committees for a while. So this is everything that Percona offers, also all the software products that you see there. But what we're here to talk about is the sharding aspect. All right. So here's the agenda, and I did it in a little fluffy way, right? So we're going to talk about what's sharding. We're going to talk about how all this began and why it came about. Why do we need sharding? And we're going to review the architecture, because you really have to talk a little bit about the architecture to get started. And then also the chunks, the balancer, and the chunk migration, which is a huge part of the sharded environment. If you're not really aware, sometimes it's that mystery box. Things are moving. Sometimes they're balanced, sometimes they're not. So hopefully by the time we finish this, you'll have a little better idea of exactly what's going on there, if you didn't before. And then, of course, the number one thing that we're talking about at any given time, the shard key selection and the strategies around that. And then we'll also go over some examples of good and bad. And then, of course, a real quick brief. I'm sure that pretty much you guys know how to shard, but I actually have basic commands in there as well. Then we'll review the changes in MongoDB that are now. And then we're also going to go through a scenario about fixing one of the problems using the newer method. So we're going to use a Refinable Shard Key. And then talk about what's coming next. So. All right, so what is sharding? Hopefully you guys have some awareness of what sharding is. But it's basically partitioning. It's scaling. It's having the ability to grow out. Back in the day, you had the larger, Exadata systems and the larger Oracle rack and the data warehouses, and then the need for the commodity hardware came along just because of the sheer data and the sheer number of servers. But sharding is a method to grow out and to grow horizontally to allow you to pretty much grow your business as you need it, not paying for everything all up front. So you have your cloud. You can do this on-prem. You can do it, your own data center. You can do it in the cloud, wherever you want to have it. Okay. So why did this all happen? Well, I don't know if you guys know the little thing I was about to pick up, but really the phone, the cell phone was the start of a lot of the massive growth that we're talking about. And the iPhone, realistically, the smartphones when they came about, and then the Android phones. But on top of that, as we've gone along, you've gotten all the additional sensor data as we come along, just more and more buckets of data, social media, and then, of course, all the devices. Now you have your television, your refrigerator, your stove, your dishwasher, your car, your self-driving cars, possibly soon enough. I don't know if you guys want to give that up yet. I'm not quite ready for that. So, but you see here the explosive growth, and it's not going to stop. So we're here in 2021, and we're seeing that we're sitting at about 100 zettabytes around through there. But by 2025, they're expecting us to be at 175 zettabytes. And realistically, at this particular point, I'm actually thinking we may pass that by the time we get there. So again, where's this coming from? The data is coming from everywhere, right? There's sensors on every device now, and you see it all around you everywhere you're looking. So there are just more and more of these connected devices. And that's what the relational databases just couldn't hold that data anymore. The joins that are required to do it were just too much. So why do you need to shard? We need to grow. We need to grow fast. We need to be able to have our apps do more. We're going to need to be more complex. More databases, hosting more applications, etc. So it's just going to keep growing, like I said. And a lot of times you've outgrown your current resources. And on top of that, now if you're in the cloud, you can get newer hardware, better RAM, better memory, etc., for less money than you did before, as long as you don't auto-scale too much. That's always I got you. So you've added new use cases, you've added new users, you've added hopefully a lot of new users, and just everyone's busier. You might need the right scopes for the throughput, you might need better performance for reading, but overall your application is probably hurting. Your boxes may be on fire, or they are already maybe toast. So we're going to go ahead and take a look at the architecture, the overview. So with the overview and the architecture, the components that are there in the MongoDB architecture, your basic one involves a replica set, and it's composed of the MongoDB nodes, data nodes. So the MongoDB is a data node, bearing node, and it's a member of the replica set. So they kind of go interchanging. The replica set really is, it's a group of MongoDB processes. They're all data bearing. If you have any arbiters, obviously those don't count. In a single replica set, you can have up to 50 members, but only 7 of those will ever be able to vote at one time. So why would you want to have more than 3 or more than 4 or more than 5? Well, 5, 6, 7, not 6, but 5, 7. You can do cross data center replication. You can do your HA, your redundancy, etc. You can have replica sets in other places so that you have lower latency. If you have, West Coast or East Coast, or if you have Asia, or if you have Europe, and you have your farm of app servers everywhere, you can have the replica set members there. You can utilize zone sharding and the global clusters. We're not really going to talk about those today because I wanted to just talk about and give the examples of the refined shard key. So, but those are some of the things that you can talk about and utilize, right? So this is where you start. And the replica set, by its very definition, it involves replication. So you're going to have your primary, and that's designated to take in all the writes. And then you're going to have the secondaries. What else can you use the secondaries for? A lot of people use the secondaries for analytics. You're going to be needing to run reports. You're going to be needing to do analytics, all the AI type stuff. If you need to run aggregations, if you want to run your back office off of that, so all these different things. So whether it's for latency, possibly using hedge reads, or whether it's just to get, no load so when you're taking your backups. Because today, two other things are also occurring. Applications are tending to be go, go, go all the time. It's not just during the waking hours here or during the waking hours there. It's more international. So I'm sure most of you guys are aware of that as well. So it's super important to have the replication piece itself ironed out. MongoDB does that for you all built in. All right. So the replication is just copying the files from the primary to the secondary. And you can also do some chaining there, right? So it's not the only way. But this all happens through the op log. So these components, we're talking about them first, but don't worry, I'm going to show you the pictorial in a minute. So they communicate via heartbeat. They're just sitting there constantly, hey, are you there? Hey, are you there? Right? And if they're not there, then what's going to happen is the other remaining members will elect a new primary. And that's a failover if it's done accidentally, unintentionally, if it happens, or it's an election if you mean for it. But either way, a step down if you mean for it to happen. But an election occurs when that happens, and you get a new primary. Okay, and so that's how the built-in high availability comes into play, right? So what does it look like? It looks like this, right? Just what we talked about. Your primary and X number of secondaries. The replication occurs via the op log, and then your heartbeats are sitting here pinging each other, making sure everyone's all right and happy and ready to play today. So great, but what in the world is one replica set going to do? It can't take care of the data that I need unless it's like the equivalent of a mainframe replica set. Now, you might think that's kind of a joke, but it is kind of a joke. It's actually not. There are a lot of people out there who are running multi-terabyte replica sets. And just to kind of talk a little bit about some gotchas that are around that. When the larger your replica sets that you run, then your management becomes more problematic, tasking, whatever you want to, however you want to phrase it. But you have to make sure it's going to take longer to do an initial sync. It's going to take longer to build the indexes on the larger data sets. It's going to take longer to back up and to recover as well. You're going to have to utilize, have more of an op log available to you to recover if anything did go wrong. So it's just a lot of things are going to take longer. Your mean time to recovery is going to suffer the larger you have. The other thing you want to think about, well, I'll talk about that a little bit later more, but you also want to think about how you want to size it, because you need to think about how your application works and how, if it pulls a lot of data, if it does a lot of sorting, or if it just does quick hits to and from. Okay, but so going again, the data is not going to go anywhere. It's not going to slow down. Most of the people come in and you need to scale, and you need to scale fast. And that makes total sense because we are in a much more get it done type mentality here now. So what happens? Well, sharding to the rescue. Again, if we pick the right shard key. So these are the most generic superhero that I could find. There we go. But sharding comes to the rescue. So sharding adds a couple of additional components to the game here. And we were talking about MongoDB sharding components. What is sharding? You're spreading the data across multiple hosts so that you can gain the resources of those hosts, and so that you can scale horizontally. You can continue to grow and grow your business. The shards are composed of replica sets. The replica sets are MongoDB processes and the associated data files. The sharded cluster is then going to be composed of the replica sets, the MongoS processes, which we'll talk more about in a minute, and then the config server replica set. All right. So again, we'll talk more about those. Sharding increases your write abilities, it increases your read abilities, and it adds other resources that you may need along the way. And it does it for a lot less than the big box mainframes used to do. So again, pictorial. I always like to do it and talk a little bit about it and then see it as well. So here's the architecture again. Your cluster, your client drivers. MongoDB supports a whole host of different drivers, everything from Node, JS, et cetera, okay? You always want to make sure that you have the right compatibility, the right versions, that you are syncing up the version of MongoDB that you're using and the correct version of your client, your driver. It's kind of like your OS also needs to be the right version. But your MongoS is your tier, it's your traffic cop. It's the one that when you come into the Mongo, you should pretty much almost always be going to through the MongoS, unless you are doing some maintenance and need to take it out of the set. So the majority of people these days, you have a farm for the larger applications. You have a farm of MongoSs. They're the processes, they're the lighter weight ones, but you need to size those according to how much sorting and how much memory you need there, because they're responsible for the sorts and the cursors and the connections, et cetera. So one connection, 1 meg. So if you have 30,000 connections, you kind of see how that goes. That's kind of what you think about when you're going. So the traffic cops, the query routers, they talk to the config servers. They keep their the cache of the config servers. The MongoDB are your data nodes, your data bearing nodes, and you get your location metadata right from the config servers, and you send it to when the query comes in, it gets its location, and hopefully it goes, if you're using the correct shard key and the correct indexing, it goes straight to the shard that it's supposed to. So, and that's more of an architectural thing again that we'll discuss a little more in depth later. Your config server holds your replica set, holds your metadata. It's your data dictionary, it's your map. So now that it is a config server replica set, it was available in 3.2, was one of the changes, but it became required in version 3.4. So it makes it faster to keep in sync with each other and faster to send out fresh copies of the cache. Those are some of the things that it does. So we'll more of that later. And then again, your shard, each shard that you have here, this is just your generic 3-shard setup. So shard, it's responsible for the data distribution. Okay, so here you have it. It's pretty straightforward there. Your data is sharded at the collection level. Okay, then that collection data is distributed across all the shards of the cluster. And each shard contains a subset that it's supposed to based on the shard key that you utilize or you choose of that for the sharded collection. So remember, even the sharded collections still have a primary database assigned to them, a primary shard assigned to them, right? The unsharded collections also have a primary database, primary shard assigned to them. So when you're making a lot of databases across your shards, make sure you spread them out across your shards. Because if you don't spread them out, then it tends to end up in the wrong place. You tend to end up with too many unsharded collections on one of your shards that is also hosting a sharded collection, and people tend to run into a little bit of contention and problems there in terms of I/O resources, in terms of disk space, and also in terms of memory and everything else that you use as you go along. So be careful with that, right? So each shard contains a subset: the config server, the data dictionary, the map, the metadata, tells you where all that is. If anything were to happen to config server, you would lose the location. Your data would still be there, but you wouldn't be able to get to that. But ever since the config server has been a replica set, that has alleviated a lot of the concerns around that. All right. So how is this data distributed? Well, now we're going to talk about chunks and splits and the balancer and chunk migrations. Okay. So this is pretty much the only exploding sun type image of exploding planet to get for the splits and to get some chunks there for you guys. So chunks and splits. A chunk holds a subset of the data, and it's contiguous. In that chunk should be contiguous range of shard key values within the shard. So, documents that you want. Mongo uses that shard key that you use it to partition the collection and to partition the data into the chunks and distribute them out. So each chunk has the inclusive lower boundary and the exclusive upper based on the shard key again, right? How big are your chunks? Well, hopefully they're not over 64 meg, because then we have another thing to work on. But your default chunk size is 64 meg. So that can be adjusted. If you have the need for larger chunks, you just need to remember that you will end up getting more chunks on a particular shard for any given time. Whereas if you have the smaller chunk size, you'll have more chunks, but obviously smaller. But you'll also see more balancing activity. So keep that in mind. Now with bad shard keys, you get the jumbo chunks. I personally had to split a jumbo chunk back a couple of years ago, but 1,923 times. So that was I think that was the record. So obviously you don't want to have to be manually splitting chunks and splitting jumbos. So you want to try to make sure that we get the best shard key possible. So you'll hear that a lot today. So jumbo chunks, they split because they've gotten bigger than 64 meg, or they've reached the other limit, which is 250,000 documents. So splitting occurs whenever there's an insert or update to a document. If you have smaller chunks, again, more even distribution across the shards, but you'll create more write and more network activity, right? Because you're going to get more chunk migrations. Larger chunks, fewer splits, fewer migrations, but if you run into problems, especially with any jump, you're going to see even data distribution across the shards by size, and the majority of the time when you have something like that happen, you'll have performance problems associated with that. Not always, but that tends to be the case. So I'll take a breath here for a second, let you guys breathe as well. Okay. So what about thing over here? So Mongo, here we go, smaller, larger. Everything's pretty much a trade-off. And you base that, you make decisions determining what trade-off you want to choose based on how your application runs, what your data looks like, how your business runs, etc. All right, so we talked about the chunks. Let's talk about splitting. So here's a jumbo chunk. Here's an example. Here's your min key, etc. Splits can be done by the balancer or manually or by other processes. So the auto splitter, it's a chunk splitter process. And so there's all the technical terminology down underneath there, but this is basically what the auto splitter does. It's going to take it sits on the replica set primary. So this is a move after starting in 4.2, they moved the auto splitter from the Mongo S to the primary on the MongoD, right? The reason they did that is because, as I mentioned earlier, more and more people are having farms of Mongo S's. And the Mongo S's processes were not aware of the size or what the other Mongos were doing. So you've got everyone shooting a Nerf gun at the same person, right? That particular person is going to be being with all the Nerfs. And that's kind of what was tending to happen. We were ending up with more jumbo chunks because the Mongo S processes did not have the most up-to-date knowledge on how big the chunks were on the primary of the MongoD, but on the shards. So they moved that over to kind of help out with that. But the auto splitter, the chunk splitter, it runs these tasks asynchronously. So boop, boop, boop. And then it can take multiple chunks at once, okay? But the server itself keeps track of the number of bytes. So the MongoD is now keeping track of that at no longer the Mongo S. So the MongoDs at any given time know how big the particular chunks are. They have a much better idea of that, right? So the auto chunk splitter over here, right? If it's oversized, not already marked for a split, then the server can send the chunk to the auto splitter to be split. Okay, and that's the split vector. The split vector takes care of all the logic of where the split point is, split at, et cetera, et cetera. You can find more chunk info, right? There's a lot of other things there around the chunk splitter, so I left the link there for you guys and gals. All right, the sharded cluster balancer. So here's the other big piece of the sharded cluster, right? You've got the shards, and then you've got the balancer. Okay, so the balancer is responsible for keeping things balanced. It's a background process, and it's responsible for knowing how many nodes are on each shard for the collection, right? And to keeping them all balanced. So one thing to note and to remember is that the balancer really keeps track of only of the count. It doesn't keep track of the size. So that's one of the reasons why you can sometimes look at your system and look at the number of chunks, sh.status, and you will see, hey, everything's balanced. But then if you look at the disk, you can see something terribly wrong, right? With one particular shard taking up significantly more. So 3.4, the balancer moved to the primary config server. I mentioned that. The auto splitter is now, the balancer's enabled by default. The auto splitter is enabled by default. So the balancer, how does it move the chunks? So there's a process, and it's called the chunk migration procedure. And that's what the balancer utilizes to move the chunks. So I'm going to go into more detail about that process in just a second. But it's always good to... So some of the changes, again, one of the things we're doing is we're kind of revisiting. We're looking at these changes and hopefully talking about how they helped or how they didn't. So 3.4, for the first time, allowed parallel migrations. So as long as you have n number of shards divided by 2, you can have the migration occur, the chunks there, the documents in there. But it can only happen, like a donor shard can only participate in one migration at a time. So if you had shard A and shard B, and they're exchanging, shard A can't also be exchanging with shard C. So that's how that works. Another new thing in Mongo 4.4, the balancer, when you have too many jumbos and you can't split them and you can't move them, then you can attempt to trick the balancer. If it has not already tried to move it and failed, then that chunk will not yet be flagged as a jumbo chunk. So if it's not yet been flagged as a jumbo chunk, then you can use this balancer setting, attempt to balance jumbo chunks and set it to true. And then it'll try to move the jumbo chunks yet. The caveat to that is that process can only consume up to 500 meg of memory. After 500 meg of memory, it's going to fail. So that's a little bit about the cluster balancer itself. Okay, and then there's the balancer. So the balancing act can be somewhat impactful if you think about it. If you have a very heavy write application and you have a lot of small write packages, then you're probably going to be doing a lot more migration activity, right? Hopefully you don't have the dreaded jumbos. But the balancer window is something you can do so that you can set that so that you do not have to run the balancer during your busiest times. That's become harder and harder with 24/7 global companies, e-commerce, etc. But you have to think about that. You have to have time to actually balance your cluster, because if you don't do that, and especially if you've not chosen a great shard key, then you're really going to end up in trouble quickly. And then the longer you put that off, the messier that it's going to be when you get there. So I definitely don't want that for you guys. Hopefully you don't either. So the balancer window, to set that, you connect to the MongoOS, and then you're going to use the config, obviously, because it's a setting there. You're going to update the window, and you're going to do an upsert. True, there's your settings specifically, and it would be a similar command to do this. So originally, this slide deck was significantly longer because I was going into a lot more detail, but I did cut it back some. All right, so the balancer. If this were an audience, I'd be asking you guys, how many of y'all have ever had trouble with the balancer, and so you thought, well, I'll just turn it off. It's not going. Or when you've done an upgrade and you've possibly forgotten to turn it back on. Either way, it is definitely best to not leave the balancer off for a long time. Think of it this way. Your balancer's off, you have a shard key problem, and you've got a cement truck that's just pouring all the cement into the point problem shard. And then when you turn the mixer back on for the cement truck, or when you try to stir it around, it's going to be very tough. And if it starts to dry, it's going to be very hard to get some of those chunks out of there and put them in other shards. So next time you're thinking about, well, maybe I don't need to set the balancer window, or maybe I don't need to turn the balancer window back on, just remember that it's going to sit there and it's going to keep filling up with cement. And by the time that you actually do have to start turning it on, you're going to be hit with a bigger problem. Now, one of the ways that you can get around as a temporary type Band-Aid for those type of performance problems, you can increase your resources. And a lot of people do that with autoscale up, autoscale down. A lot of companies do that. A lot of cloud providers do that, and they keep you running. But look what happened to Slack over last January. Everyone had gone home for the holidays, and then everyone came back. Well, since those servers, they had been spun down for 2 weeks, more or less. Then when they came back, there was a storm. There was some other problem, but there's actually a great RCA that Slack put out on that outage. I think they were down for about 5 hours. Now, that wasn't Mongo related, but it just kind of goes along with the point there. So the majority of the time that you're seeing these performance problems is because there are other things going on. You've got some aggregations that are, have too many arrays in there. Or you've got, you most likely have a bad shard key, or you're not using indexes in either the majority of your queries, or you're not using the shard key in your queries at all. So luckily, going forward, there'll be some things that you can do around that, but we'll talk about that later, right? But work to fix those underlying issues, whether it's, these days it's normally going to be something within the database, whether it's the indexes or whether it's a shard key or whatever. But the longer it stays off, the more resources you're going to have to put into there to prevent the problems from coming back, because they will if you don't fix them. And then by the time you get ready to re-enable it, that cement is going to be dry, right? So leave it on if at all possible. And the balancer window itself, per Mongo, they say it's got to be long enough. The balancer window, you can't have a 4-hour balancer window when you're busy 18 hours of the day. You've got to make sure that the balancer window is set long enough to complete all the migration of the data that you inserted during the day. Now, if you're primarily a read application, then this is less applicable to you, right? But if you're heavy write, or even 60-40 write to read, you still need to take this into consideration. And this is something that's super important. Earlier I talked about the massive increase of data. You know, just more and more sensor data. And it's not just sensor data, it's coming from everywhere. It's coming from the analytics, from AI, it's coming just from everywhere, right? That people gather your privacy data, all different types of data. But as those data changes, the way the data has been used has changed, then activity patterns are going to change as well. So it's important to make sure that your balancer window, that you adjust that. If you make a major change to your application, keep that in mind with regard to the resources that you're allowing and utilizing, but also to the overall support for your application and for your environment overall, right? Because most people are running more than one database data store, and they're running, you know, a lot of different elements in their platform these days. You know, back 5 years ago, everyone, you know, polyglot persistence. Well, you know, here it is. It's in its finest. You use Elastic possibly for this. You might use MySQL or Postgres for transactions, and Mongo for your unstructured, for your you know, unstructured type data that you need just for document stores, whatever. So I said we're going to talk a little bit about what the chunk migration protocol. And this is important again because a lot of people don't understand it. Some people think it's a black box. A lot of people do understand it, but some people do think that it's a black box. So this is how it happens underneath the covers. The balancer does a lot of different things, but the data migrates from one shard to another, one shard at a time, one chunk at a time. Sorry. So data migrates from one shard to another, one chunk at a time. Okay. So the whole parallel thing, but in actuality, from one chunk to another, it's only going to go to one. So the designated shards, you've got your donor and your recipient. They're going to sit there and they're going to keep talking and telling each other their state. The donor is going to be the driver in this process, and it starts through the series of components in the move chunk command. So during that whole thing, there's 7 basic steps. There are different ways of explaining it. I've got the one from GitHub, but there's also one in MongoDB docs. I originally had both in here, but we saw no reason. So to start the migration, the first thing you do, you start it. Your donor says, okay, I've got a chunk and it's going to be moving, and I'm going to stop all of the chunk migrations that are going to be coming and going here while this is done. Okay. And then what happens is you literally makes a copy of that chunk. So you start the cloning of that chunk. But the donor's going to say, yes, this is where I'm going to send it. Everything's good. And then it's going to send the received chunk start. So the recipient's going to say, okay, I'm going to start receiving. This is all messages. These are all processes that are going on. And so the migration process then starts. The recipient initiates the transfer of the documents from the donor. And it does that by constantly, hey, migrate, clone, migrate, clone, migrate, clone. And then it's going to insert the documents that it's fetched and asked for and that it's received. Okay, so this is a lot of words. So I should have actually divided this up into a couple more slides, but you should look at the top things. The transferred queue modification. So step 3, the first batch completes, right? And then these changes that have been waiting are queued up, and then they're going to be sent over by the transfer mods command. And that's just going to be only your inserts, your updates, and leads, because the reads don't matter in this particular thing. So that's the initial batch plus the initial modifications. You wait till the recipient has cloned the documents, or a timeout happens. So if it's taking too long, it'll time out. Okay. So, but you're looking for the status of a study. Then you move on to the next one. This is called the critical section. So the recipient has done the cloning, and the donor says, okay, I'm critical now. I've got this going and everything's hung up and we can't do anything else until everything's finished. So I'm sitting here waiting. So all rights to the donor are delayed until the received chunk starts. Message just sends it back to the recipient, and then that will start the migration process. Okay, so there you go on, migrate, clone, right? The next step is the commit on the recipient. So still in the critical section, the received chunk commit is telling the recipient, go get anything else that's missing. Check it out there, see what else you're missing. If you're missing any chunks, go ahead and grab it. Using the transfer mods again, so the donor over here is still locked. Once that's all done, then finally, the received chunk commit returns the status to the donor to unlock it. So again, they're talking. And the final thing, of course, the config server always has to be updated. The donor is going to send the config server commit chunk migration command to the config. It's going to refresh all the caches. And until that happens, then all reads are also. So for that short period of time between 6 and 7, the reads are also suspended there. And once that is complete, it starts a whole nother process that I just briefly mentioned here, and that's the Orphan range deletes. Again, this is the same link down here at the bottom for that. So the Orphan range deletes. So remember earlier I said that it made a copy. So you're actually cloning a copy. Well, you're shipping the copy over, but you're leaving the original on the donor. And so the Orphan range deletion process. So a lot of times when you're having performance problems, you may see Orphan range deleter, range deleter. And that's what's happening. It's having to clean up the original chunks from the donor. Okay. All right. So what do you have to worry about? What do you have to look out for? In MongoDB before 4.4, if you had a failover during the delete portion, that last phase of the chunk migration, then it could cause orphan data. Not only could it cause orphan data, it could sit and end up spinning there so long that it could lead to a primary crash. So here's this particular thing. Here's for 3.6. You see the message there. Deletes last longer. If you have multiple deletes getting backed up, using resources trying to get rid of chunks that it needs to, then you can see a possible crash of your primary, and you'll leave a lot of orphan data behind, right? In 4.4, your chunk migration is made more resilient during the failover of the delete phase. So orphan documents are actually cleaned up, even if there's been a crash during that phase. So that's a great thing. So I know I'm talking about 3.6 and sometimes I'm talking about 3.4. Now 3.6 just recently went EOL at the end of April. A lot of customers, when they went from 3.6 to 4.0, a lot of them saw some performance degradation. There was like anywhere, depending on who you read and who you follow on the benchmarking test, between 10 and 30% degradation in write performance, and a similar one to read performance. So there's some additional things that some people forgot to update, some parameters like wait for delete, etc., types of things that they'd had in for years that were contributing causes. One thing that we saw, though, that was not that contributing cause, anyone who was doing massive aggregations tended to have a little harder time when they upgraded from 3.6 to 4.0. So the advice there is to get to 4.0. Don't set your FCV to 4.0 yet. Make sure everything's good for a couple days. Set your FCV to 4.0. Let it sit for a couple days, and then move on out to 4.2. Right? Because 4.2 adds a couple of 4.2 is where they moved the process for the auto splitter process. That's one of the changes too. So again, I'm interspersing the changes throughout here, but then we'll also do a review at the end. All right, so now we're going to do the fun stuff. So the fun, the tedious, the time that you should spend a significant portion of your life to, if you want to gain that time back and not having to be down and stressed and pulling your hair out. So super important there. Take your time, do your due diligence. Look at your data, know your data. A lot of times a document looks like this, but that's the beauty of Mongo. It's unstructured or semi-structured or structured. You may change it as your needs, as your application grows and changes, as the way that people use it. You may be surprised. So you may have fields in it midway through that you didn't in the beginning, or at the end, you may have a couple fields, or you may have gotten rid of some fields. But either way, know what your data, know what your patterns are, what the documents look like. But also make sure you know how you're going to use them. Make sure that you know if you have batch updates, if you have batch deletes, if you have people running aggregation reports 5 times a year, 6 times, monthly, daily, nightly, if you have people who come in and just hammer your system, one customer who's just like in there all the time, and doing whatever it is they need to do, just make sure that you're aware of these things, because all of those things come into play when you're architecting your system, but even more importantly, when it's time to troubleshoot. Because if you can remember, oh yeah, I've got, you know, this customer over, I don't know, in Texas, it's always causing me a problem. I'm in Texas, so I can say that, right? Okay, but anyway, and the other thing is keep in touch with how fast your data is going to grow. Daily, weekly, monthly, etc. How many people do you know use it, and how's it going to go? So I'm going to speed up a little more here. All right, so strategies: take your time, diligent, know your data, high cardinality, easily divisible, know your access patterns. How are you queried? Okay, how many people will use it? When's your peak time, your slow time? When's normal? What's your ratio of reads to write? Write distribution, read distribution. What activity is more important to your business? Where do you make your money? How do your queries work? Are you going to be targeting one? You're going to go to all of them, right? Read locality, you're going to sort and limit the queries. So think about that when you're doing your memories, etc. But these are things like the last 10 tweets, or the last 10 chats, or the last 10 whatever. That's your read locality. Here's some different strategies for sharding. Use a large number of smaller size shards. You need more write scopes, smaller docs. You don't need a lot of memory because you don't do a lot of sorting. You're just bang, 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 bang. Medium, okay, you do a little bit of both, right? You're pretty balanced, right? Read to write. You need some extra write scopes, but you don't want things spread so far apart there's going to be a problem. And then the last one, we're seeing more and more and more of this. And it's not always necessarily a good thing, but smaller number of larger size shards. Like I mentioned before, whenever you'd have to do an initial sync, whenever you have to build an index, when you have to do backups, but also eventually you're going to hit a bottleneck in terms of if you're a heavy user, you're going to start hitting a bottleneck in terms of the performance that you see. Unless you're extremely, extremely doing a great job with your application. So keep that in mind, right? Okay. For heavy write applications, if you're not going to be doing a lot of massive queries that would be static gather, it's still the best recommendation to do _ID for that. So this is just an example of what I said a minute before. Okay. I really want to get to the example of the refinable shard key. But just different cuts. So here's at the top the actual use cases themselves, right? Small mobile analytics, a marketing app, you know, a chat board. The medium, it could be like your social media app, your connected, your user data, product catalog, and then your small number, large shards, your big ones, right? Your game money, right? Game money. So a lot more device information, that type of thing going there. So how do you shard? You do your profiling, query analysis, your access plan. You look at everything you have, you look at your data, you select what you think is going to be the best option for the shard key. And it says best because it's always a trade-off again. You create your index, you disable the balancer, you're going to enable, if you're not already there, enable sharding at the database level, then you're going to shard the collection or add the shards. So when you add shards, or when you shard the collection, keep in mind that it's initially going to be impactful. That's another place where size comes into play, because the larger a shard is, the more chunks it's going to have, and the longer it's going to take to dole those out. So when you're done, you enable the balancer. Okay. So shard key selection, analysis, and consideration. You create your index, you enable sharding, you shard the collection. I left out the balancer commands here just for space. Okay. So now we're going to talk about specific bad examples of shard keys and the impacts. This one's still one of my favorites. You can kind of use Snapchats there, but get rid of Vine, add TikTok, although I hear Vine's growing again. But if you pick a shard key, if you're dealing with social media type applications and you shard on what type of app it is, you're only going to have like 5, 6, 7, 8, 9, 10. That does not have a good high cardinality, and it's not very distinctive. And you're going to have buckets that get very, very full in the wrong way. Here it is. If you shard just on social media, it's bad. And you only have 7 or 8 buckets, okay? And some of them are going to be full. Their buckets are going to be totally full. So you're going to have 1 or 2 shards that are just shard. And then you have other shards for, I don't know, Vin, or whoever, that are just sitting there snoring. So yeah, your shard keys definitely matter. Okay, so that's one example. Another one, you have a user ID. and it's one user is a user. And that's like super, it's not hashed, right? This could be for like social media type apps as well too. Or, Twitter, where one person is just massively famous. These types of things, if it's not hashed, you're gonna have that one shard just getting hammered and hammered and hammered. Another example here would be a transaction ID, or a compound example here. If you had a compound key for like transaction ID, but then you had status. Status is only going to be like successful, fail, et cetera, et cetera. So you definitely want to keep that in mind. Those type of things. Oh, so here's this chunk thing. This was an actual example, right? 6119 to 292. And then in terms of space, you just had to keep extending this and extending this and extending it. You see how problematic that can be very quickly. And you also see how long it takes to unwind that. The time I've had to split like the 1,900 whatever, it took literally like a month to do the manual splits, to have them all done so that it would not impact the business. So bad shard keys, bad performance. Hotspotting for writes, hotspotting for reads, creating demo chunks. You're gonna have disk imbalance, IO problems, an unhappy dog, slow queries, slow performance, and then crashes and downtime. And then on top of that, potential, if you don't have your offlog long enough, potential data loss or corruption, and ultimately unhappy customers. So, all right, so we're there with that. So we're doing pretty good here. This good thing, oh, this is live, yeah. So the quick summary of the changes, and then we're gonna talk about the refinable shard keys. So what happened in 3.4? 3.4, the balancer moved from the MongoOS to the config server replica set, the primary. The balancer started doing parallel chunk migrations, and the config server required 3.4. Okay. 4.2, you got a lot more. 4.2 is a busy little bee. So distributed transactions, retriable reads and writes, new index builds, mutable shard key values, which means you could change the shard key values. Before that, once the value was in, it was in. And once you had a shard key, you couldn't change it either without dropping and recreating or doing a dual write type situation. And again, the larger you get, the harder it is to clean that up. Okay. The auto splitter moved. And also you got faster step downs. That's primarily because of the collaboration between the config servers. 4.4. Here's the one that I talked about before. Chunk migrations made more resilient, and the attempt to balance the jumbo chunks true. So remember, only 500 meg of memory, and then it goes kaput. Okay. So now we're going to talk about, so you have these bad shard keys. What are you going to do? The old way, fix it, dump and restore, drain it, do all the drains and all the manual attempts to split shard, whether you're, do it by split at or whatever. If you do the rename method, you're going to end up having to hack your config server. It's easy to potentially, if you fat finger something, then there goes your config server. Obviously, always have a backup of everything before you attempt to do any of this. So now we're going to talk about the refinable shard key. So the docs are here, right? But starting in 4.4, you can use the command or the procedure refine collection shard key to change it. Okay, so you can only change it by adding something to it. You can't change what's already there. And if it's a single field shard key, you still has to have the existing field first. So your prefix has to remain the same. You can only add a suffix to it. So consider, for example, the earlier example, a transaction ID and a status. If you have it on transaction ID and it's not sharded and you're getting hammered because, I don't know, you had a big transaction, or user ID, you have one super busy user and you have status, that's not going to help you. So in that particular situation, you would probably end up using underscore ID as your second field. So refine shard key, you refine it, try to get rid of some of the jumbo chunks that you have. So now we're going to look at the actual commands and doing it, right? Yeah, don't pay attention to that. Feature compatibility version. For this to happen, you have to have FCB set to forward. In order to set FCV to 4.4, you have to turn the balancer on or off, or it hangs. Okay, so you're going to run that against the admin database. Depending on what type of instance you have, will depend on where you end up running. For standalone, obviously, you're going to run against the standalone MongoDB. If it's a replica set, you're going to run on the primary. Okay, and you have to have all the others available. So you have to have at least 2 while you take the other one out. For the sharded cluster, you're going to run it on the Mongo S. Okay. So before you do all this, you're going to actually look at your data. Didn't put those slides in here, but you're going to take your balancer because you're going to have to turn it off. You're going to look at your data to determine what you want to add. You're also going to look at what indexes you have existing. Okay, but daisy. So you're going to stop the balancer, and then you're going to change your FCV if it's not. Okay, again, it'll hang if you don't have your balancer off. So then you're going to check it, make sure it's what you expect it to be, and then you're going to refine you're going to create the index. Okay, so, and you're going to add this particular thing. The difference here is you're adding ID 1. Okay, because you can't have, in 4.4, you cannot have an additional hash field. In 5.0, I believe that's when they start you can. You can have a compound hashed key, but here you can't. Since index was already hashed, then that you had to go that way. So create the index, then it's going to work. And then you run your refined shard key collection. That succeeds. And then you're going to check your sh.status, and you see, yes, it has changed. Okay. So a couple of caveats around that. This is only going to impact data that comes in new. And also now you can have empty shard key fields. Right? You can add a shard key. So if your structures change from way back when you first started and you want to have a different shard key, then you can do that. But it's better to add that data in before you do a refined shard key, right? Because if you add that in, then you're going to have an index, and it's going to be, take longer to do there. You're going to take more space, the size of the additional index. If you're not going to be using an index that you had previously for a shard key, make sure you get rid of that so you're not doubling up. Okay, but refinable shard keys will let you do that, but it's only going to be for that. The other thing is with refinable shard key, this was not a test on that type of system, but if you have a very large system, if you have a multi-terabyte system, you have to think about what's going on under the covers, because you're updating the metadata, you're updating the config server, and when those things are happening, there are going to be some locks that are going on under the covers. Okay, so you really need to keep that in mind and think about it, because everybody's going to be like, especially with 5.0 coming up. I'll talk about that in a minute. But everyone's going to be like, oh, yes, we finally changed the shard key. That's the one thing that I hated so much about Mongo, because we had this terrible shard key and I was stuck with it forever. Now you're not going to be stuck with it forever. You can modify it with the refinable shard key by adding a suffix to make it more distinct and to give it more, breakdown ability, more visibility. Okay. So now that you've done that, don't forget to restart your balancer, because that's super important to do. All right, so what's coming up in 5? Here are the things we know about, just the main ones, right? There's a lot of different ones, but time series collections and time series collections from the looks that I've been doing in the Jira will also be able to be sharded, which of course. So the API flexibility, there's going to be some ability that if you were using an older API, driver, etc., that you can tell it which one to use. There's quite a few tickets with some stalls. Talking to a peer of mine who's been digging into that, and he was saying that there are still quite a few stalls there, right? So we may be able to, some of these sharding, resharding parameters, may be able to run them both command line and at startup. So there's a Jira issue out there, and those are the ones that that's looking at. So, but the biggest one, of course, is the fully changeable shard keys, aka resharding. And so think about, again, what's it doing under the covers? Right? Is it doing strictly a dual write? Is it making a copy and then it's writing to a new place? If so, you're doing dual writes. And then you have to think about the cutover. The larger your system is, people asking about 20 to 24 terabyte shards. Now, think about your op log on that. Think about how long it's going to take you to back up. Think about how long it might take you to recover. That's a lot of things to think about. Yes, you have fewer hosts, but in a way, you're now just running multiple Exadata boxes or whatever. So make sure that your system that you're designing is manageable and that it's doing what you need. Because you're also at the same time, when you have shards that large, you are putting equivalent, a little bit of a bottleneck at your disk level or at your memory. Memory, you can add more memory, but keep that in mind as well. Okay. So with that said, here's the end of it here. In the end, everything always comes back to pick the best possible shard key that you can go up front. I know it's sometimes a lot of work. I remember when I first started doing it, and I was just poring over all the profiles. That was back when the profiler was really all you had to utilize. Today you have new toys and new things. Okay. All right. So new toys, new things, and then that's it. Here's the thank you. It's got my information there. So please, reach out if you have any questions or any comments. If you want to just talk about what you think is going to be going on. But really looking forward to trying out some of these new features. They'll be coming out in the sun. In the meantime, know that Percona Server for Mongo will be incorporating the community changes in and adding the additional components on the top, like we do the enterprise ones for security and auth and logging, etc. So I'm going to go ahead and stop sharing. Yes, thanks a lot. Appreciate it. Thanks, Hans. Thanks, Paul.